You may remember way back in the second unit, we were talking about multiplying vectors. And we said that there were two different ways to multiply vectors. The first way we said was the dot product. So remember that took two vectors A dot B, and then the end result of that was a scalar. It was ax bx plus ay by plus az bz. So now the second way that we can do it is called the cross product. Okay, and the cross product is also known as the vector product, and we'll see why in a second. So if we have some vector A, and now we have some other vector, actually let's change these up slightly. Let's say we have, this will be our vector A, and I'll explain why in a minute. We've chosen this convention, this is B, and then we have an angle between them, theta. Okay? The definition of A cross B is equal to the determinant of x hat, y hat, z hat, ax, ay, az, bx, by, bz. Okay? So you can either remember how to do determinants, and the easiest way to solve one like this is, so you go down this diagonal. So you say we have x hat, and then ay bz, y bz minus by az. You have y hat, so to do the y hat, we can extend this over here, and we'll add another x hat, y hat. So this is ax, bx, ay, by. So y hat is going to be az bx minus bz ax, and then the z hat is going to be ax by minus bx ay. So this is the formula for the dot product. Some people just choose to memorize this formula. I find it easier to write the determinant and to calculate the determinant of it. But however you remember it, that's up to you. And notice that this is a vector, okay? And because this is a vector, it has to have a direction. So what's the direction? Well, in this case, we have A and B are in a plane. So the direction of the vector that we get out of this is going to be coming out of the screen. Okay, so it's going to be perpendicular to A and B, and coming out of the screen. So I draw, so this dot and the circle around is kind of like an arrow coming toward us. Okay. In the other case, we'll see in a second that if we had A and B reversed, and we took the dot product of that, the cross product of that, then it would be into the screen. It would be in the opposite direction. Okay? In other words, A cross B is equal to minus B cross A. Okay? Geometrically, what this means is now let's look at if we have a three-dimensional vector. Okay, if we have some vector b and a with an angle theta between them, again, the cross product is going to be at 90 degrees to both of those vectors. But if we extend this out, and if we draw another b on top here, and we draw an a after the b, we have this this part in here is a parallelogram. Okay, this parallelogram, the area of this is equal to the magnitude of the cross product. Okay, so this would be A cross B, and then if we did B cross A, this would be B cross A. So again, it's negative A cross B, so it's a vector going in the opposite direction. And we're not going to use this too much in this semester. We're really just going to kind of use the bare bones of this to do some things with angular momentum now. But I will warn you that you will use this a lot next semester. So when you're taking 114, you're really going to have a lot of this cross products. There's no way to get around these when you're doing E and M. Okay, but in this semester, the most useful form. So you may remember with the dot product, we said that A dot B is the magnitude of A times the magnitude of B cosine theta. Well, fortunately, we have a similar formula for the cross product. If we look at the magnitude of A cross B, okay, not the direction, just the magnitude of it, this is going to be the magnitude of A times the magnitude of B times sine theta, where once again theta is the angle between them. And so you see from this that if A and B are in the same direction, the cross product is 0. So remember, the dot product was 0 if A and B were perpendicular. The cross product is 0 if A and B are in the same direction. If A and B are perpendicular, then we see that that gives us a maximum value of the cross product. Okay, so your book has some problems on this, and Halliday, Resnick, Walker has tons of problems on this. So I would definitely work some of those, because you are going to have a cross product problem when you take this unit's exam.